So today we are going to start with the chapter Mensuration, class 10, 17.1. Here the sum tells we need to find the total surface area of a solid cylinder that is given radius as 5, height as 10, and we have to leave the answer in terms of pi. So total surface area, we are denoting it as TSA, okay? So the formula is 2 pi r bracket h plus r. Just substituting the values, accepting the pi, and we are getting the answer as 150 pi centimeter square. Now for sum number 2, it is telling an electric geyser in cylindrical shape having diameter as 35. So when diameter is given, so radius will be 35 by 2 centimeter. So now we need to find height is also given as 1.2 meter, and neglecting the thickness of its wall, calculate the outer lateral surface area and capacity in liters. So outer lateral surface area formula is 2 pi RH, and we are substituting the values that are given in the sum, and we are getting as 13200 centimeters square. Now for capacity, we know it as volume, and putting the formula as pi r square h, substituting the value and just getting the answer as 115500 centimeter cube. Now for sum number 3, it tells a school provides milk to the students daily in cylindrical glasses of diameter 7 centimeter. So from it we know 7 centimeter is the diameter, so the radius will be 7 by 2. If the glasses is filled with milk up to a height of 12 centimeter, find how many liters of milk is needed to serve 1600 students. So the number of students is given as 1600, diameter to radius we have already found out, height is 12. So now volume of one glass will be, we know the formula pi r square h, just substituting the value and getting it as 462 centimeter cube. Now we need to provide milk to 1600 students. So total quantity of the milk that will be needed, the volume of glass into that students, number of students. So just doing it and just dividing it by liter, because from centimeter cube we need it in liters. So we divide by 1000 and we just getting the values, that is 739.2 liters. For sum number 4, here a rectangular tin foil that is provided with base is 22 and height is 16 centimeter. So it needs to be wrapped to form a cylinder. Now for this, the length is given as 22 and breadth as 16. When foil is wrapped, it forms a circle at its base. So from that we know the circumference of a circle, that is 2 pi r. So we know circumference is given as 22 and we need to find the value of r. So we substitute and get the value as 7 by 2. Now for volume of a cylinder, we know pi r square h. So we are just putting the formula and getting 616 centimeter cube. For sum number 5, how many cubic meter of soil must be dug out to make a well of 20 meters deep and 2 meters in diameter? So 20 meters deep it should be, and diameter is 2 meters. So from this we know the radius will be 1. Dividing by 2. So we know the height and we know the radius. So volume will be pi r square h, because that should be in the shape of the cylinder. So volume after substituting comes to 62 by 6 by 7 centimeter cube. Now for the second part, we need to find the inner curved surface area of the well. One above to be plastered at the rate of 50, and we need to find the cost of the plastering. So the inner curved surface area, so curved surface area formula we are putting, that is 2 pi r h, substituting the value and getting as 880 by 7 meters square. Okay, the previous one will also be meter cube and this is also meter square. Now for rate of plastering, we know the rate per meter. So the cost into 50. So we are getting as 6285.70 rupees. For sum number 6, a road roller in shape of a cylinder has a diameter 0.7 and width 1.2. Find the least number of revolution the roller must make in order to level a playground of size 120 meter by 44. Now we know the diameter, so we can take out the radius. Width is given as 1.2. Curved surface area 2 pi rh, just substituting the values of r and h and getting it as 2.64 meters square. Now we need to find the area of the playground by curved surface area gives number of revolution. So just substituting the value, area will be 120 into 44, that is the area of the playground, and the roller will be curved surface area, that is this one. So just substituting the values and getting 2000, that is the number of revolution.